All right, go ahead and get started. We are in section 5.5. And so before we jump down to the other questions that we have, the problems in this section, just going to go ahead and review some of these because it's 5, 6, and 7 we're going to be using now for the last problems that are more algebraic in style. So I just want to go over these for you. So for this, we have log base b of m to the r. So for these properties here, you can, the r that's up here, you can bring that down in front of the logarithm. And so for that one, we've got log base 3 of 5 to the 8. You can bring that down in front. So we went over these yesterday, but we're just kind of reviewing them again just to make sure, because these algebraic problems kind of use these three properties. So we just want to take a look at these before we jump back into those algebra problems there. So for this, we've got the if multiplication turns into addition, and we have division turns into subtraction. So now that we've reviewed those, these are the three main ones that we're going to be using for the algebra ones. So we'll go down, and this is where we left off last time. So these other are actually these right here. These other two we did yesterday. These are numerical ones that have numerical answers, but we'll focus on the algebra ones now in this section. All right, so for this, it says we want to separate this and split it up as a sum or difference of logs, express powers as factors. So this right here, express powers as factors, what that's going to mean is any kind of exponent, you're going to bring that down in front. So instead of a power or an exponent, it's going to become a factor because it's now being multiplied out front. So we're going to do that on this one here. The first thing we want to do is change the, whenever you see like a square root or some kind of radical, it's better to write that as a fractional power, because since it says express powers as factors, we'll have to bring that down eventually anyway. So we're going to do log base 9 x squared, and then I'm going to write this as 3x minus 5 to the 1/2 power there. Okay, so that's the power, that's square root. Now that we've done that, we're going to use the rule number 5 we just talked about to separate this. So I'm going to do x squared, and then plus, we have to put another log because the rule says that one log turns into two logs. So we're going to do another 9 here, log base 9, 3x minus 5 to the 1/2 power. So that's the first step, is to use rule number 5 to separate this and make it a plus. The last step is, it says express powers as factors. So we're going to bring these down in front, log base 9 of x. So the 2 comes down in front. This is using rule number 5, is what we're doing now, the property number 5. 2 comes down in front, and then the 1/2 will bring that down in front here. 1/2 log base 9 of 3x minus 5. All right, so that would be the final answer now. We've turned it from multiplication into addition. We've brought the powers down in front. So that's as far as we need to go with it. That's complete. This next one, we want to do the same thing. Now, an ln is a log base e. We talked about that last time. So all these rules still apply to ln's. We'll just put ln's in our answer instead of logs. Okay, so first we notice that there is a division happening here. So what I would do first is write it out as subtraction. This is using property number 7 this time. So property 7 allows us to take division and turn it into subtraction. So these are the same properties, again, the beginning of this section, ones we went over last time. Each of these numbers are going to come down in front. So we bring down the 4. So 4 ln x plus 5 minus 3 ln x. Okay, so we just bring the powers. We're using rule number 5 to finish it, so that way there's the powers are no longer there and they're down in front. And that's as far as we'll go. We need to go with that one. So again, these don't have numerical answers because there's x's in it. They're just going to be expressions, is what you're going to be running. It is possible that you may do more than one log rule in a single problem. You might be doing pluses and minuses, and so rule number 5, 6, and 7, this problem uses all three of those. So first thing is, again, if you've got a radical there, some kind of root, let's go ahead and rewrite that as a rational power. So we're going to do x minus 2. So this is a cube root, so that's going to be a 1/3 power. And then x minus 1 to the 4th power. So that's the first step, is to write it out with the 1/3 power there. Next thing we want to do is we're going to do these one at a time. So let's next turn the division into subtraction. So I'm going to write this the same as we had before, but then I'm going to put a minus sign, and I'll put log base 4 of x minus 1 to the 4th power. Okay, so we're first starting by doing the division turns into subtraction. That's using property number 7. Next, this first one is one that we can break apart using property number 6. The multiplication turns into addition. Now I'm doing both of these separately, but if you want to go ahead and do all this in one step and just jump down this line that I'm doing now, that's okay. So this whole thing would be now expanded. Okay, so you could have gone from the first original problem where we wrote it from here and just gone right down to there if you want. So as you do more of these, you may be able to kind of jump down to that one and not do the intermediate step, but I'm going to keep showing you the intermediate step just until you get the hang of it there. So for all this here, we have a plus and then we have a minus. Now the last step is we still have to express the powers as factors. So we have to bring the 5 down in front. So 5 log base 4 of x minus 5. We have plus 1/3 log 4 of x minus 2 minus 4 log 4 of x minus 1. Now, some questions that I usually get on this one is the 4 and the 4 there. Some students will say, well, these match, so won't that turn into a 1? So that's all going to go away, and I'll just be left with x minus 1. That's a common mistake that I usually see people make on the test, okay? But I want to go over that for a second, because even though this 4 and 4 match, let's go back up to the properties, and we have to look at if that turns into a 1 or not. Notice that property number 2 says that that number has to be immediately after the log in order for it to turn into a 1. So like this here, log base 2 of 2, or if it was a 4, it'd have to be a 4, log base 4 of 4 equals 1. Now in this case, we got the 4 outside the log, so that doesn't pertain to property number 2, does not work there in that case. I just wanted to go over that just to remind you of how that works. Because again, this is a real common mistake that I see, and you don't want to make that mistake. Okay, the 4 is out front, so there's no property, nothing I can do to this. I just have to leave it as minus 4 log base 4 of x minus 1. All right, so this next one, I'm going to do a little bit differently than the way it was done in the notes. Okay, so in the notes, I brought the 1/4 down and I expanded and did everything. Well, instead, I'm actually going to factor this and then raise everything to a power of 1/4. I'm going to do that instead, just to show you there's multiple ways that you could do that. First thing, though, is inside the bracket, I do want to factor this because there might be a case where I can cancel it out with the 1 in the bottom. So let's factor it and see if we can cancel something from the bottom here. We have x and x, and then factors of 6 that add up to -5. They both have to be positive or negative, so we want to do a -2 and a -3 there. Multiply to make positive 6 and add to be -5. Nothing cancels here. I got a minus and a plus. But the next step I'll do is I'm going to take everything inside and raise it to a power of 1/4. So I'm going to do x minus 2 to the 1/4, 1/4 here, x minus 3 to the 1/4. On the bottom, I have a 3 and I'm raising it to a power of 1/4. So power raised to another power, you have to multiply exponents. So that is going to become a 3/4. So 1/4, 1/4, and 3/4. So again, that's done a little bit differently than the way I did it in the notes, but some people might find this approach a little bit easier instead of bringing the 1/4 down in front and having all that afterwards. All right, so now that I have this, we're going to separate this. The division turns into subtraction. So these two things are still together. And we're going to put a minus ln x plus 2 3/4. Okay, so now we've separated that, so there's no more fraction. But we notice that there's still a multiplication going on here. So for the first two, we're going to split those up with a plus. That's using, again, property number 6 allows us to do that. Put my ln here, ln x minus 3 to the 1/4. And then this part is still the same, this one in the end. Okay, so we have that. The last step, bring everything down in front. So 1/4 ln x minus 2 plus 1/4 ln x minus 3 minus 3/4 ln x plus 2. Okay, so we brought all the powers down in front, and that's as far as we need to go with our answer. So we factored it. We raised everything to the power of 1/4. That's what we've done a little bit differently than the notes. And then we used log properties to expand all that. Okay, so that would be your final answer in the bottom there. Okay, so this next one is probably the hardest of this type that you'll see of this kind of problem. This one has a bunch of different things going on, and there's a couple different properties that we'll be using here as well. So first thing, there's no roots to deal with here, so we can just immediately go into turning the division into subtraction. So I have log 5 of 2x to the 4th, x minus 4 minus log 5 of 5x minus 3 to the 5th power. This is something that we can turn into a multiplication. So log 5, we have 2x to the 4th plus log 5 of x minus 4. And then we have minus log 5, 5x minus 3 to the 5th power. Okay, so it may look like we're done and we're ready to bring the powers down front. However, if you have, let's do this off to the side here. If you have log base 5 of 2x to the 4th, this is not equal to log base 5 of 2x, okay? That is not true. Now, the reason why is because the 4 only applies to the x. The only way this would be true is if there are parentheses around the entire 2x, then you could bring the 4 down the front and that would be true. But in this case, there's no parentheses around this. So what that means is that the 4 is only connected to the x, not the whole thing. So it's incorrect to jump the 4 because then you're jumping the 2. So here is the correct way of doing this problem. What we're going to do is we're actually going to do one more separation step. And we're going to separate that into, because these are like two different terms multiplied together. So we're going to do 2 times x to the 4th. So you're going to do log base 5 of 2 plus log base 5 of x to the 4th. Now this one is still okay. Now we're going to do the same thing with this. The 5 actually counts as something additional that we're multiplying. So what I'm going to do is in the parentheses here, I'm going to go ahead and separate this just like that. Now notice what I'm doing here. I'm putting a parenthesis around the entire thing. I have to do that whenever there's more than one thing on the bottom of the fraction. I have to put them all in the parentheses. That's because the negative needs to apply to both of these things, negative and negative, because both things with a negative will end up on the bottom. If I did not put these parentheses here, then I would have a minus log and a plus. And that means if it's a plus, it would end up on the top, which is not correct. We want it to, originally it was on the bottom. So that's why I need to either have two negative signs in front of this, or I can leave it in the factored form like that. I can, either one is fine. Now, the last step, what I'll do is I can bring the 4 down in front. This one is still the same. Now, inside here, log 5, that was that property number 2 I talked about a little bit earlier. If the base and number afterwards are the same, we can go ahead and change it into a 1. So we do want to go ahead and do that step. And then I can put a 5 here, and I can do a 5, log 5 of x minus 3, x minus 3. I can either leave my answer like that, or if you want to distribute the negative and make it -1 and -5 log 5, you can go ahead and do that as well. So either one of these, either way, it's fine. But this is probably the most complicated of this type of problem you're going to get, because we have a bunch of different properties that are going on there. We have to be careful with parentheses and things like that. Notice again that this 5 and log 5, that does not turn into a 1. The 5 has to be immediately after, like this. So that kind of problem, you just want to be careful about when you're able to change it into a 1 or not. It's got to be separated like this, where the 5 immediately comes after the base. That's when you can do that. So, you know, this is your final answer there, or again, you can distribute the minus sign through. That's your, either way is fine, and it'll be accepted in my open math. We're going to now do problems where we're going to be going in reverse. We're going to take the expanded version, and we're going to turn it into a single logarithm, is what it says. So we want to turn it into a single logarithm. They're 1 log only. So we're actually going to be doing our steps in reverse. The problems that we just did, the last step is we would use property number 5 to bring the power down in front. So now that becomes the first step when we're combining it to a single log. The first step would be to take these powers and put them back on top and turn them back into an exponent again. So now the factors are going to become powers. What that will look like is we have log 6 of x to the 1/2 will just go back up on top there. And then we have the 6 here, log 6, x minus 2, and that's going to be a square. So both the powers in front, or both the factors in front, came up and turned into powers. The last step is we want to combine these 2 logs into a single log. Now the single log is going to have a base 6, just like the other 2. And then the plus turns into multiplication. Just the opposite. We're still using property number 5. We're just using it in reverse. We're saying the plus is going to turn into multiplication. Now notice that I don't have log 6 x to the 1/2 and then times a log x minus 2 squared. There's not going to be a log times a log here. The property works to where the 2 logs are going to turn into a single one. So if I have the plus, it'll turn into multiplication, but then there's only 1 log there, not 2. So that's going to be, this right here is going to be your final answer. We're writing that as a single log without negative exponents. And that's it. That's all you would do on that one. All right, let's do another one of those. Same thing, if you have a natural log, you can still use the same properties. Now, the 2 that you see inside here, that doesn't go on the outside of the parentheses, because the 2 has to be out front in order for you to bring that up. So this first one, there's actually nothing we can do with that for right now. So we'll leave that alone. For this, since it says we want to write this without negative exponents, that means that we want to just bring the positive exponent up only. So negative I'm going to leave out front. I'm only going to pick the 2 and move it up on top. So now I have this. So that's how you do that. If it's negative, you just bring the number itself up there. The minus means that this is going to turn into division. Okay, it's using rule number 7 in reverse. Again, I have, when we look at this, we don't have ln on top divided by ln at the bottom. It's ln of the whole fraction at once is what you're doing. So you can kind of think of this as like a bracket. You don't need to show the brackets there, but that's essentially what it is. It's ln of all this stuff that you see. Now, if there is a problem where it looks like we can do some factoring, you want to go ahead and do that. Sometimes the questions themselves, they're going to give you like a keyword. It'll say something like fully simplify your answer, something like that. Okay, so if you see something like that, that kind of problem, that's a hint that you probably have to do a little bit more as far as the with that. So if it says something like simplify your answer, something like that, that's a hint that you probably need to do a little bit of reducing or something like that. So let's go ahead and take a look at this next problem. So this one, this problem here, this is going to be done one more time. Difference of squares we'll do first. You can keep the brackets there, that's okay. And then what's going to happen is the x plus 1s are going to cancel, and you just get x minus 1 over x plus 1 because there were 2 in the bottom, and now there's going to be 1. So that is your final answer on that one. So although the instructions here did say that, there are a few with the homework that may say something like simplify your answer. And if it does say simplify your answer, you want to double check and look just to make sure when you do all these kind of problems, just make sure there's not anything more you can do as far as simplifying, because it wants the most simplified answer here. So that's why we want to do that extra step with that. Okay, now this is the most complicated one that you're going to see of this type, because we have a whole bunch of terms that are they're all out there. We're going to rearrange these terms first before we use any log properties. We want to put the ones that are positive together first. The ones that are negative, we'll put those together. Now the order doesn't matter in how you do all this. This is all plus and minus. That's why we're allowed to rearrange these and put them in any order we want. So I'll just start from the end. There's a log 3, 8. That's positive. And this next one is a 3 log 3x, that's positive, and then this one here, log 3 of x squared plus 2. So we'll put those are all positive again. Doesn't matter what order we write these in, I just wrote them all like that. Then we're going to do minus. We have minus this one here, log 3. Oh, it's a 4 there. And then, oh yeah, there's one up front. So minus 2 log 3x. Okay, so now we have them, at least the positive ones and the negative ones are together. Now the reason why we're doing that is because eventually we're going to put all the positive ones are going to turn into multiplication, and the negative ones we'll put those together as well. First though, we're going to move these powers up on top. So I'm going to do at plus 3, I forgot. So the 3 is going to go up on top. So log 3x to the third. So I'm going to move the 3 up on top. That's using property number 5 for that. This next one, we can just leave it alone the way it is. Now these over here, what I want to do is take out the negative. I want to factor out a negative for both of these. So that's going to turn into a plus here, but then the 2, I want to put that on top of the x and make it x squared. All right, so what I did again was there's 2 negatives here, but I pulled the negative out so that way that inside sign becomes a positive, and then that power I just moved on top like this. Now the reason why I'm doing that is because now I want to combine everything with a plus. I'm turning it all into multiplication. So for this, I have log 3. So it doesn't matter how many of these you have, you're just going to multiply all those because they're all plus signs. So I'm going to do 8 x cubed x squared plus 2. Okay, so all those end up being multiplied together. And then this one here, these two get combined together as well. So I have log 3. So all 3 of those turn into one single log, and then these two turn into a single log. Now that I got a subtraction, that means I need to do a division on that. 8x cubed x squared plus 2 all over 4x squared. And as before, if you see anything that can be simplified further, you do want to go ahead and do that. What we notice here is that we can divide this 8 divided by, so we're going to do log 3. 8 divided by 4 is 2. A cube and a square, subtract exponents, we just get x by itself, and then x squared plus 2 would be all that's left over. Okay, so now we've canceled that out, and so now this is going to be the final answer. So that's the hardest one that you'll see of this type, because you got multiple terms to deal with there. But if you just group them all together, it's not too bad. You're taking it through step by step. We can use one rule at a time when we combine these together. Okay, so that's the final answer. That's been fully simplified. Next thing in this section is something that's called the change of base formula. All right, so this one right here is a formula that we can use to change a base. Remember, I mentioned yesterday that your calculator only does 2 different types of logs. It does a log base 10, and it does a log base of an e. So it does 2 different types of bases your calculator does. Well, this change of base formula allows us to use our calculator to find other types like this, like log base 5 of 8. That's something that we could not use the equal basis property. We did a couple problems yesterday, like a log base 4 of 64, for instance, would be one that you can set equal to x, and then you can use the equal basis property to find it. However, we can't do that with log base 5 of 8 because you can't write the 5 as a power of 8 and so forth. So this is where we're going to use change of base. Now, change of base formula, the b is whatever base that we want. So we probably would want this to be a log base 10 or a log base e, so that way we can do it in the calculator, because there's questions in the homework that ask you to get a decimal value. So we'll need to do this in our calculator. All right, so using this formula, you're going to take log base b of the big number of the original one and log base b of the smaller number. The b, again, can either be a base 10 or a base e. So I'm going to do this problem 2 different ways that you can do that. First of all, I can just take a log base 10 of 8 over log base 5. Or I can do log base e, which is an ln. I can just do ln of 8 divided by ln of 5. Now, either one of these is okay to use with the equal basis formula. The equal basis, change of base formula. Change of base means that these bases are both the same, whether they're log base 10, both of these, or it's log base e. But I want to do either one of those, because these are the only 2 logs my calculator will do. So if you do that, you're going to get 1.29. So 2 decimal places, you should be getting 1.29 is the answer. Now you can either do that with logs or with ln's. It doesn't matter which one you do. And the thing that you can't do is you're not allowed to do like a mix and match. So you don't want to do like a log 8 and ln 5. You have to be all logs or all ln's in order for you to do that. And so that's all you need to do on that, is just plug it into the formula. So the formula again is, if my base was 10 here, for instance, you would just do log base 10 of the big number, log base 10 of the smaller number. So that's all you have to do for change of base formula. Okay, so let's do another one. Okay, now this one we have 2 of these together. Now 2 of them means that we want to do a change of base formula for each one separately. Okay, so we'll do one for each. Now you probably want to do either all of them in ln's or all of them in logs. You don't want to mix and match on this one either. So it doesn't matter what one we do. I'm going to use ln just simply because it's one less letter to write. That's the only reason why I'll use ln. So I'm going to do ln of 8 divided by ln of 3, and I'm multiplying this by ln of 9 over ln of 8. Okay, and I could put these into my calculator separately, but this is actually one problem where I don't need to use the calculator at all because I can see some things are canceling. So I get ln 8s are going to cancel, and I end up with ln 9 over ln 3, which we could put that into a calculator, but just since we've been working with properties in this section, let's go ahead and do this one by properties. Not every one necessarily will turn into something like this, but this one it does. The 2, so I basically changed the 9 into 3 squared, so that way it's the same base as the bottom one. And then I can use rule number 5 that says that you can take the 2 and put it down in front of the ln, and then the ln's cancel out like that. And so your answer is going to be 2. If you were to do this in the calculator, you would also get the same answer of 2 with that. If you did that right here, ln 9 divided by ln 3, you should get exactly 2 as your answer. So now you have a tool in order to find bases of different things. And so we can just change the base formula. Will always work for something like that. So if your calculator does not do these special bases, then this is what you want to use, change the base formula. Okay, and that's the last problem that is in this session. So we've covered now all the material that's on the homework for this week, but we do need to keep continuing because we have more material. This is going to be this next section we're covering now, 5, 6. This is going to be what we're going to be continuing with next time, because we're not going to be able to finish this whole section today, but we're going to start it. And I'm also going to open up this homework for you after this is done. I'll make sure that the homework is open so you can get started on this section, because next week we have a review and things going on, so and we have other sections to cover as well. So I just want to make sure we are able to have time to cover all this material by next Thursday, because next Thursday is our review. Okay, so this section 5, 6 is taught. It will be on. This will be on next week's. So this section is due next week, but again, I'll open it up for you ahead of time so you can start working on it based on what we do today. This is all talking about solving exponential and log equations. Now, some of these are going to look similar. These may look very similar to ones we've done before, and yes, that's true. The ones here with the single log, we've actually done these two problems, similar problems in another section, but they kind of give them to you again as a review. This is actually kind of talking about the 5.4 section where we talked about changing between log form and exponential. That's the idea here. So we're going to do to do this problem, you're going to take the base, raise the number after the equal sign. It's going to equal the whatever you have left over. So changing it from log form to exponential. 2 raised to the 4th power. The base raised number after the equal sign is going to equal whatever you have left over, 3x. To the 4th power is 16. So then if you divide both sides by 3, we get the answer of 16/3. Okay, so 16/3 would be your answer. Next one. Log base 5 of 4x plus 9 equals 2. So this, you have the base raised to the number after the equal sign equals whatever you have inside the log. Okay, so that's the first step for setting it up. 5 squared is 25. We're going to subtract 9 from both sides, and we'll get 16. 25 minus 9 is 16. And then we're going to divide both sides by 4. So for this problem, x equals 4. So all the problems that you've seen so far in this section and previous sections only had a single log. But now the new stuff that we're going to be going over is ones where you have more than one log. So we're going to take a look at this problem. So this problem, there's multiple ways that you could do this, but I'm going to show the way that we're going to solve all the other problems in this section, even though this particular problem, you don't necessarily have to do the process I'll show you. It's the same process I will do for future problems there. And I'll explain that a little bit later, what I mean by that. First thing you want to do is you want to raise the power up if they have one of those. Okay. Now at this stage, there's two different ways you could solve this. I'm going to show you both methods. Okay, so this first method only really applies to this particular problem. This is a method that you can do here. And I don't know what the name of this method actually is. Apply a base of 7 to both sides, maybe. So I'm going to do that. I'm going to make, basically, I'm turning both of these things into exponents because I can make use of the property we talked about in the previous section. If you have a base raised to the log of that same base, that means we can essentially cancel out that and just make it x squared. And then these 7s cancel out and I get 16. So that's a way that you can cancel logs on both sides, is to do that. Then if you take the square root, we get -4 and 4 as the two answers. Now, whenever you have more than one answer, you have to make sure you check your answers within the original problem to see if it works. Notice that if I take -4 and put -4 in here at this stage, not my first line here, the original problem, I just have it just like this, I'm not going to be able to do that because -4 is not in the domain of logs. When we talked about the graphs last time in 5.4, that says that the domain of logs is only positive numbers. So if any number you have for an answer makes something inside the log negative, that answer needs to be eliminated. So for this problem, the only answer we have is 4. That is the answer to this problem, is 4. Now, I told you that there are more than one way of solving this. So now what I'm going to do is the other method, and this other method on the right-hand side, this is the one I'm going to use for all the remaining problems. I'm going to use this method. So that's why I'm going to go ahead and show that. You still do the first step here. You would bring the 2 up on top. But then what I'm going to do instead is I'm going to now subtract the log 7/16. And I'm going to have it equal to 0. This is actually what you're going to be doing on future problems in this section. We're going to do the same steps here. All right, so log base 7x squared minus log base 7/16. So I'm getting them both in the same side of the equation. Then we're going to use a log property to turn the division, the subtraction into division. So I do that. So get all the logs on one side of the equation and use log properties to combine them to a single log. Now we're going to change from log form to exponential form. 7 raised to the power after the equal sign equals x squared over 16. So I just changed it from log form into exponential form. Anything raised to a power of 0 is 1. And then if you multiply both sides by 16, then you get that, and of course you'll get the same answers as before. So that's another way of doing the same kind of problem. So it may seem like, well, definitely the left-hand side is easier, and I would agree the left side is easier for this particular problem it is. However, for future problems, you might actually have something else after this that's not a log. And if you have something like that in that case, then unfortunately this property that we did by doing the 7, that's not going to work, because then you'll end up with something else over here, and you're not going to get everything to cancel out, because if you have more than one thing on one side, this property you're not going to be able to do, unfortunately. So then you'll have to use the second method by setting it all equal to 0. And in fact, that's what we are going to do for all the remaining problems that deal with logs. We're actually going to use this process where we bring everything all over and set it equal to either 0 or a number. You know, if there's a number here, then that's okay as well. So let's do that for this problem right here. Okay, now this problem is a little bit different because now everything here that we have does not all contain logs. Okay, so we're going to now move one of these over to the other side. So the first step that I would do for this problem is I would bring all the logs over to one side of the equation. Okay, so I have that. Okay, now that I have this complete, this is a little bit different than the last problem because now I have two logs, but I have something else that's not a log. Okay, so this, what I'll do is I'm going to do this kind of second method I showed in the last problem. I'm going to do that in this case here. Okay, so this is the only way that you can really solve these. You can't raise everything to an 8 because the plus sign prevents us from doing that. If we have only one log on this side, then yes, certainly we could do that to get the answer. But if you have a plus or a minus sign in between with two logs like that, then you can't do that power. It's only if you have a log on one side and one log on the other side, then you can do that process. The process I'm talking about is this left-hand side. That only works if you've got one log on one side and one log on the other, then you could do that. If it's something like this, it's different. So in this case, what we'll do is we're going to combine this together into a single log, just like that. So now I have this. Now, if it's a single log, then you are in fact able to apply the 8 and put the 8 down here and the 8 down there. So you can either change it from log form to exponential, or if you don't want to do that, you can put an 8 down here and an 8 down there. But I'll go ahead and change it into exponential form. It's the base raised to the number after the equal sign is going to equal everything you have left over. So this step right here, what I did was I changed it from log form to exponential form. The base raised to the number after the equal sign equals whatever you have inside the log. So now I have this. In order to solve this kind of problem, be careful. You don't want to do x plus 7 equals 8 and 2 minus x equals 8. That's not going to work. That only works if you have a zero. It's a zero product principle. We don't have that here. So instead, what we're going to do is we're going to multiply this out first. So I'm going to do 8 equals, I'm going to multiply this. I'm going to get 2x, and I have minus x squared. I have plus 14, and then minus 7x. So I'm going to do all this first. Then what I'm going to do is I'm going to simplify. So I have 8 equals, so if I add the like terms, I have negative x squared. I have 2 minus 7 is negative 5x. And I have plus 14. And now you want to get it equal to 0 and then factor. So that's the way you want to do that. So instead of setting x plus 7 equals 8 and 2 minus x equals 8, instead expand it, get it equal to 0, and then factor. So I'm going to subtract 8 from both sides there, and I get 0 equals negative x squared minus 5x plus 6. Now, a lot of times I'll see students will make mistakes if they try and factor with a negative x. The negative throws them off. So what I'm going to do instead is I'm going to take the entire equation, both sides, and multiply it by negative 1. Okay, so I'm going to apply a negative 1 to both sides. That's okay as long as you multiply both sides by the same thing. Multiplying this by negative will give you a 0. This negative is just going to change all these signs. Positive x squared, positive 5x, but then a minus 6 you'll have. So all you're doing is just changing all the signs like that. It's easier to factor if you've got a positive in front of the x squared. So that's why we did that step first. We're going to look for two numbers that multiply to make negative 6 and add to be 5. So I can't use 2 and 3 this time because one of them has to be positive, one's negative because I got a minus 6 that's here instead. So I'm going to use a 1 and 6 factors. And if I do a plus 6 and a minus 1, that will work because they multiply to make negative 6 and they add to be positive 5. Now I can set both of those equal to 0 since I now have it equal to 0. So x minus 1 equals 0, x plus 6 equals 0, x equals 1, x equals -6. Now, both these answers we get, whenever you have these log problems, you want to take each answer individually and put it back into the original one and make sure you don't get a negative inside the log. So if I put a 1 in here, I get 1 plus 7. That's okay. That's positive. 2 minus 1 is also positive. So I know for sure that x equals 1 is one of my answers. But now I need to check this one. Now, just because we have a negative number doesn't necessarily mean that automatically it's not included. Okay, if I put -6 into this expression, I get -6 plus 7, that's positive. But then 2 minus -6 is also positive. So this is a case where actually both answers do work. So in this case, I have two answers here, both 1 and -6. So just because it's a negative x doesn't necessarily mean you're just going to automatically cross it out. You got to go back and check in the original problem and make sure that whatever you have inside the log is positive. Okay, so in that case, both of these give you positive numbers inside. That's fine. As long as it doesn't get a 0 or a negative number inside the log, then it's okay. All right, so both those will be our answer. Let's do another one of these type where we have to combine logs together. So let's do another one. Okay, so this next one conveniently has all the logs on one side of the equation for us. So we can immediately turn this into multiplication. So log 2 of x plus 11, x plus 11, and then I have times x plus 7, and that equals 5. Okay, so the plus turns into multiplication there. Next thing we're going to do is we're going to change this from log form to exponential. 2 to the 5th power equals, and we can go ahead and multiply this out, or we can do that next step. It doesn't matter when you want to multiply that. I'll multiply it out in the next step. Okay, so the base raised to number after the equal sign equals all this. So now it's an exponential form. Be careful when you do 2 to the 5th power. If you do this too quickly, you might accidentally put a 10 down there. Remember, it's 2 multiplied 5 times. So it's going to be 32 is what we have there. Then I want to multiply all this. So I get x squared plus 7x plus 11x plus 77. So just doing the FOIL, multiplying all that out. I'm going to add the like terms together. So I get 18x there. Then I want to subtract 32 from both sides. And I get 77 minus that. That's going to give you 45. Okay, so we're just subtracting everything, getting all equal on one side. Now that I have a quadratic that's set equal to 0, my next step will be to factor this. We're looking for two numbers that multiply to make 45 and add to be 18. So 9 and 5 doesn't work. We can do 3 and 15. That's a combination that'll work for us. So 3 and 15. And then since all these are plus, all these will be plus here. 3 times 15 is 45, but you add them together, it does equal 18. So that's factored correctly. X plus 3 equals 0. X plus 15 equals 0. Subtract the 3, we get -3, and we get negative 15. Okay, -3 and -15. Now remember, we have to go back to the original equation and plug both these numbers in separately and make sure we don't get a negative inside the log. If I put -3 in here, -3 plus 11, that's 8, that's okay. -3 plus 7 is a 4, that's okay as well. So I know that x equals -3 is okay, that fits the domain. Now let's try -15. You see a problem here? If you put -15 in here, -15 plus 11 is a negative number. So we don't even have to check anything else. If any of these logs turn negative, if you plug this in there, that answer needs to be eliminated. Okay, so this is not our answer because it's not in the domain of the log. So you always want to go back and check each time to make sure if you plug the number into the part inside the parentheses, that part inside needs to be positive. So negative 15 plus 11, that's negative number, and negative 15 plus 7, that's negative anyway also. So that means that we have to cross that answer out because that answer is not in our domain. So that's the one thing you got to be careful about when you do problems with logs, that to check and make sure that the answer you have works. So now we've seen it's possible that both answers could work, or one answer could work. There's also a possibility that no answers will work as well, and we'll take a look at one of those examples. Okay. Let's look at one with a minus. So we've done some ones with plus signs so far. So now let's do a problem with a log where we have a negative. Okay, so the negative ones, so they're going to, negative is the difference between this problem and the one we did before is because we have a negative sign, we're using property number 7, which means that this is going to turn into a division instead of a multiplication. So I want to combine these together into a single log. They're both on one side of the equation, so we can do that right away. X plus 3, but then you're going to have over x plus 5 equals 1. All right, so in this case, we're turning the subtraction into division. Okay, so now that we have this, we're going to change it from log form to exponential. 2 to the first power is going to equal x plus 3 over x plus 5. Okay, log form to exponential. The 2 raised to the power 1 will equal this fraction. From this point, we want to get rid of the fractions. So what I can do here is I can make that a 2 over 1, and I'm going to cross multiply this. So these diagonals multiply together 2 times x plus 5. That's going to equal these diagonals multiplied together 1 times x plus 3 is just x plus 3. Or I could just multiply both sides by x plus 5, gotten exactly the same answer. So either way you want to look at that, either way is fine. We're going to multiply by the 2. So 2x plus 10 equals x plus 3. We want to subtract x from both sides. And when we do, we get x plus 10 equals 3. And then we just want to subtract 10 from both sides, and we get x is equal to negative 7. You want to take this answer, put it back into the original. Now, if we put that in there, negative 7 back into where the parentheses are there, negative 7 plus 3 is a negative number. So therefore, this answer is no good either. So since that's the only answer we got, and the only answer we got doesn't work, that means you're going to put no solution for that. And there is some buttons that you press if it has a solution or not. You'll either type the answer in, or it'll be a second button saying there's no solution. So you have a choice on what to select there. But in this case, if our only answer doesn't work, again, it doesn't work because it doesn't matter what log you plug this into, it causes you to have a negative number inside the log. So whenever that happens, you have to just automatically cross out that answer. And so since there's no other answers to test, that's why it's no solution. Let's do another one of these. This one here, we don't have the logs on the same side of the equation. So the first thing to do here would be to get all the logs on one side of the equation. So we're going to do log 3x plus 1. We want to subtract log 3 2x minus 1. Okay, so we're going to move that over so we get both logs on the same side of the equation. That equals 2. Now that both logs are on the same side of the equation, the purpose for doing that is to use a log property to combine the two logs into a single log. Minus turns into division. So log base 3 of x plus 1 on top. We don't need the parenthesis part there, so we'll just do log 3 x plus 1, and the bottom 2x minus 1, and that equals 2. Okay, so division happens here because of the minus sign. Property number 7. Now we're going to change it from log form to exponential. You want to take the base 3. You're going to raise it to the number after the equal sign, and that's going to equal x plus 1 over 2x minus 1. So always the same process every time. The 3 squared is going to turn into a 9. Remember, it's not 6. It's going to be 3 times 3, or 9. At this stage, you can either multiply both sides by 2x minus 1, or you can cross multiply. It doesn't matter. Either way you do that, you're going to end up with this here. 9 times 2x minus 1 is going to equal x plus 1 right there. So we're just multiplying both sides by 2x minus 1. Now we're going to multiply the 9 through each of these. 18x minus 9 is going to equal x plus 1. We want to subtract the x from both sides, so let's do that next. 17x minus 9 equals a 1. Now we're going to add 9 to both sides. 17x equals 10. Okay, and then divide that. We get x equals 10/17. Now what I want to do with 10/17 is I want to use my calculator to get a decimal version of that. So 10 divided by 17, the decimal is going to be, it rounds to about 0.6 is what that would round to. Okay, so I just needed 1/10 is okay to round that to. So that's 0.6. Now I want to put 0.6 back into the original equation up here and make sure I don't get a negative inside. That's what I want to check. 0.6 plus 1 is 1.6. That's positive. That's okay. Now this next one, I have 2 times 0.6, which is 1.2. 1.2 minus 1 is also positive. So I do want to, my answer is going to be, just one answer this time, 10/17. So I do want to write my answer as a fraction if possible, but it's good to change it into a decimal just so you can go back and plug it in to make sure you're not getting a 0 inside. So that's what we want to do for that. Okay, so 10/17 will be your answer on this problem. Okay, next thing, it is possible that you might have more than one log on a problem that you have. So this time we have 3 logs that we want to combine together. All right, so this one, we want to do the same thing. We want to combine all the logs together. Now the first two are, they have a plus sign. So what I'm going to do first is to combine those together. I'll put the x first, but the order doesn't matter on that. You're multiplying these together. So I'm changing these first 2 logs, I'm combining into this single log, and I still have the rest of it that I didn't do anything with. All I did was combine the first 2 logs together. The plus turns into multiplication. Next thing I want to do is combine these 2 logs together into a single one. The minus means that this is going to turn into division. So I have log 2 of x times x minus 3 divided by x plus 2. I still have a 2 on the other side. So I've combined all the logs. So that's really the only difference. If you've got 3 logs, you're still going to do the same process. You just have to combine them all together. So you might have to do those in steps. Again, if you want to go from the original problem directly down to the second line all at once, that's okay. It's okay to skip that intermediate step if you want. If you know how it changes into that, that's okay to jump down to this step here. But then we want to change it from log form to exponential. So the base raised number after the equal sign is going to equal x times x minus 3 over x plus 2. Okay, so now we've changed it from log form to exponential form. We can do 4 over 1, and then I'm going to multiply this, x squared minus 3x. We'll have to multiply it out anyway, so I'll just go ahead and do that in this step. Cross multiply is the next step. So 4 times x plus 2 equals x squared minus 3x. Next, we're going to multiply each of these by 4. 4x plus 8. And the idea here is you want to get everything all over on one side of the equation because you want to get the get it equal to 0 because we see here it's a quadratic. So quadratics, you need to get them equal to 0. So I'm going to subtract so if I subtract the 4x over like that, we get 8 equals x squared minus 7x. And then subtract the 8, 0 equals x squared minus 7x minus 8. So now we have that quadratic. We are now going to factor it. Factors at 8. Numbers that multiply to make 8 and add to be 7. Really only 1 and 8 are the only ones we can use there. And one's positive and one's negative, so we're going to do a negative 8 and a positive 1 because they add together to be negative 7. Finally, set them equal to 0. We get x is equal to negative 1 and x is equal to 8. We set both those equal to 0. Now we want to go back to the original problem at the top here and plug this in. Right away, I see that if I put negative 1 into the first one, it causes, so remember, you got to check both of these. So even though negative 1, it makes that part positive, because negative 1 makes this one negative, if any of these are negative, then you have to cross out that answer. So negative 1 into here, negative 1 minus 3 is a negative. That number is not in the domain because whatever you get in the parentheses has to be positive. So I need to cross out my answer of that. So now I'm going to check the 8. 8 minus 3, that's a positive number. That's okay. That's okay here. 8 plus 2 is positive. So 8 is the only answer that is the answer to the whole problem. Okay, so that's the single answer. By the way, the answer negative 1 would not have worked in the second log either, because that would automatically be a log of a negative number, so that wouldn't work. Okay, so 8 is the only answer that we have on that one. Now, some other problems in this section are ones where we have exponential style problems or other ones that we want to solve. In previous sections, we did the equal basis property in order to solve these, but unfortunately, we can't do that this time. And that's because you can't write these as the same base. You can't write 7 as a base of 3 and so forth. So because of that, that means we have to use a different process here in order to find that. All right, so for this, we're actually going to take the log of both sides. Now, what I want to do is I want to get rid of the x from the power so I can solve for it. The only way to do that is if I throw some kind of a log in front of this that allows me to bring the x value down in front, and I can eliminate the x from here. So that's the idea. So since I can't use equal basis property, which would be easier, but unfortunately I can't do that here. I can either put a log, log on one side, or an ln. I want to use either a log or an ln, just in case it asks me to write a decimal. Then I can put that in my calculator and get an answer. You could really use a log of any base here that you want, but I'm just going to use, in this case, I'm going to use a natural log. I take the natural log of both sides. Again, the only reason why I'm using a natural log, one less letter to write. Okay, so I don't have to put log in a base. ln is just easier to use. That's why I tend to use ln's when I do that. So I put an ln on both sides of the equation, and then that allows me to take the x and put it down in front. So I have x ln 3 is going to equal ln 7. Now that I have that x is a factor now, it allows me to divide both sides by ln 3. Okay, so now that I have that, I can divide those out, and my answer is natural log of 7 over natural log of 3. Then I can put this into a calculator if it asks for it, but some of these will just ask for the exact answer. So if it just says the exact answer, it may also put something like you may use ln's in your answer, something like that. And so it'll say something like this. So you can just use the ln's in that part. So I'm trying to find one. I'm looking at the homework here. You see, yeah, it says type an exact answer. So if it says exact answer, that does mean that you do need to put the natural logs in there for your answer. This next problem, okay, we did this. This is actually the same problem that we did in the previous section. I just want to show you a different way of doing it. Now, in the previous section, I changed this from exponential form to log form, and I solved for it that way. Here's another way you could do the same kind of problem. Because there's an E, I specifically want to use only ln. Now, the last problem, I could have used either ln or a log. Whenever you have an E in the problem, you definitely want to use a natural log on this. The reason why is because we know that if natural log and E are together, it ends up canceling itself out. So that this right here is the same thing as if I have log base B of M. That was a property we had in the previous section. So in this case, I actually do have that because I have a log base E of E raised to a property. So because of that property right there, that means I can just change this to x plus 5. That all goes away, and I have ln 4. Then the last thing we do is subtract. And this is the same answer we got before in the previous section. We just did it a little bit different way. So instead of changing it to log form and going about it that way, instead you can take the natural log of both sides, use a property, and that cancels that out to get this. Okay, so that's the way you can do that. All right. Well, I think that's all I'm going to do. I think that's enough for us to move. This one takes a little bit long. These other ones take longer to do. So we'll just go ahead and hold off on those until next week. I've actually finished almost all of the 5.6. You should be able to do at least 3/4 of the problems you should be able to do in this section. So I will go ahead and open this one up for you so you can work ahead on it if you choose to do so. This will not be due until next Sunday, but I will open it up today. So at least if you want to do that over the weekend, if you want to stay a little bit ahead, then you can. So with that, I'll go ahead and end this lesson now in case you have any questions. Does anybody have any questions before we end here? All right, doesn't seem like anybody has any questions. Thanks for attending. Enjoy your weekend. I'll see you all. See you all back next week. So next week, just to give you a run through what we're doing next week. So we do have lecture on Monday, Tuesday, and Wednesday. That's actually going to finish up all the material for this course. Next week, Thursday, is going to be a review, and then after that, our last week of class together is just going to be actually basically either tests and reviews. So the last week of this class, the 8th week, we've got test 3 on a Monday, and then Tuesday, Wednesday is going to be review for the final exam, and the final exam is going to be next week, or it's going to be on the Thursday of the last week. So it's really 2 weeks from today is when the final is going to be. And then the review that we do in class, we're just going to be going through the sample exam. We're actually going to do both versions of that since we have time. I'll do version A one day and version B the next day. So that way we have all the problems we look over and do that. That's going to be, we'll do that the last week of class. So we really only have 3 more days of new material. So next week, Monday, Tuesday, and Wednesday will just be all new material. Next week, Thursday again, is going to be the review for test number 3. So with that, enjoy your weekend. I'll see all you guys next week. Take care.